Welcome to Understanding the NEC Part 2. In Understanding the NEC Part 2, we'll discuss chapters 5 through 7, special circumstances, special occupancies, communications. We'll talk about a little bit in chapter 8 as well. So we'll cover quite a gamut here too. It should last around 2 hours. Now, most states require follow-up questions after these online classes. So what will happen is you will take this as a required part of your online training. Probably every 15 or 20 minutes or so, random generated questions will pop up, and just make sure that you're sitting in front of the computer to answer those questions. You have a very short period of time to answer that, and that's for feedback purposes. If you're not expecting any more classes after this one or any more hours after this 2-hour section, then questions will pop up. You'll have to answer the questions. After the questions are answered, your certificate will pop up. You can print it off and save it. And then after that, the course is completed. It logs it to me, it sends a course completion verification to you, and then it also will be logged with the state through me. So that's your sequence of events that we're going to go through here. Enjoy the rest of the presentation. Again, the Understanding Part 2 will cover roughly chapters 5 through 7, but a very, very small section at the end with chapter 8 as well. So, with that being said, we're going to go ahead and forge on. Understanding the NEC, Part 2. Chapter 5. And remember, in Chapter 5, that we're starting our special circumstances. However, if when you're in chapters 5, 6, and 7, you don't have any references to some of the things you learned in chapter 4 or any modifications, then all of the first chapters still apply. The purpose for chapters 5, 6, and 7 are to simply go back in and modify the first 4 chapters if it's applicable to fit a certain circumstance or application. Chapter 5, Special Occupancies. Special occupancies are fairly straightforward, and they may be a little bit difficult to comply with, but their basic purpose for the way they want things installed is pretty straightforward. Special occupancies are an area where, because of the environment, proximity to a certain environment or people, or numerous other factors, contribute to the products or the methods by which they're installed, they require special concern. Remember that when we're talking about special occupancies, not all the information derived in the NEC comes solely from the NEC. They know that there are other industry leaders in this area, and they draw from the NFPA Articles 497 and 499. 497 is the recommended practice for the classification of flammable liquids, gases, and vapors, and hazardous locations of electrical installations in a chemical process. 499, NFPA 499, is called recommended practice for the classification of combustible dust and of hazardous locations for electrical installations in chemical process areas. So let's dig into Article 500, hazardous locations, where we're going to talk about areas where fire or explosion hazards could exist because of the flammable gases, vapors, combustible liquids, or combustible dusts, or fibers could occur. 500.1, the scope. Now remember, anytime you see the word scope in these code books, the word scope is indicative of an overview of a chapter. So 500.1 deals with the scope of Article 500. Articles 500 through 504 cover the requirements for electrical and electronic wiring and equipment for all voltages in Class 1, which is flammable or combustible gases, vapors, and liquids. Class 2 ignitable dusts, and Class 3, ignitable, but usually not explosive, fibers and flines. So let's look at those individually. And the first thing we're going to look at is Class 1. Flammable or combustible gases, vapors, and liquids. The groups that are covered are groups A, B, C, and D. And group A deals with acetylene, B, hydrogen, C, ether, and D, hydrocarbons or fuels and solvents. Now, keep in mind, as we go through the hazardous locations, there are several different terms that I'll use, and they're fairly easy to keep separated, but it's worth noting at the beginning here that you're going to run into classes, which basically tell the type of the danger, whether it's combustible gases or combustible dust or something like that. And then the groups, which narrows down to the specific type of danger, the very specific type. And then you'll also see divisions. Divisions are basically indicative of how dangerous is it. Is it there all the time? So you've got suspended vapors or dust in the air, so we always have a fire explosion hazard. That would be Division 1. Or is it normally contained and usually does not present a danger, but the threat is still there in the case of an accident or a breakdown, like in Division 2. So Division 1, normally explosive and hazardous. Division 2, normally not in explosive quantities for a Class 1 type of scenario. Class 2, ignitable dusts. The groups that you'll see covered here are Group E, metal dusts. Usually you're going to see electrically conductive and explosive flakes of metal. Group F, carbon dusts. And Group G, flour, starch, grain, combustible plastic, or chemical dust. So in this class of ignitable dusts, you've got Division 1 and 2. Division 1, you're going to have normally ignitable quantities that are suspended in the air. Division 2, normally not sufficient suspended quantities to ignite. However, accidents could happen because the dangers obviously still exist. Class 3, fibers and flines. Okay, generally here, the dust that we'd be talking about would fall into the group that best typifies the chemical makeup of the dust. So you may actually have to go into the NFPA articles that we had spoken about earlier, which are NFPA 497 and NFPA 499, to figure out exactly which types of dusts that we're talking about. But the groups that are covered here usually deal with textiles and woodworking. They're easily ignitable, but not likely explosive. And here your Division 1 means it's handled or used in manufacturing. Division 2 means it's stored or handled in storage exclusively in manufacturing. So you'll remember your Division 2 accidents could happen because the danger is still there, although it's a diminished likelihood that it would happen. So your divisions versus classes. Divisions versus classes. You've got your classes that are going to name the type of danger. Your divisions are going to tell how much danger is present, as we spoke about earlier. Division 1's the most dangerous. Danger is always present. This is going to be your most expensive area to install anything because it's going to have to be the safest devices that are out there. Division 2, it's still dangerous, but the material's normally not in enough quantities to be dangerous. So the danger is still present and could pop up in the accidental situation, whether it's a breakdown or a spillage or something like that, but normally the danger is contained. And it's also usually got a secondary approach to safety, which deals with positive mechanical ventilation to keep the Division 1 components out. And remember, your groups are divided into A through G for the gases and vapors and liquids and dusts and all that kind of stuff, which we just spoke about. They're located specifically in Class 1 and Class 2 when you're talking about A through G. And Class 3 dusts are going to be a little bit more complicated. So that group is going to have your assignment based on the type of chemical dust makeup. And one other thing that's important to review right here is you can install a Division 1 piece of equipment in a Division 2 space because Division 1 is going to have all of the most strict safety requirements, which makes it most expensive. So those devices are going to be able to be installed in the Division 2 area, even though you probably wouldn't install them in those areas unless specifically asked to by an AHJ. Division 2 locations would generally not be able to, or Division 2 approved items would not be able to be installed in Division 1 area most of the time. We'll look at our first device right here, 500.2. We'll look at a couple of definitions. Dust ignition proof. It keeps dust from getting in and heat, arcs or sparks from getting out. Pretty simple. Dust ignition proof equipment been enclosed in a way that keeps dust from getting into the inner components and doesn't allow any of the other stuff to get out. So you'll notice there the red label that indicates that it's dust ignition proof and also will indicate what location or temperature rating that can be installed in as well. Dust tight. Dust tight is constructed so that it'll keep dust out. It's as simple as that. It doesn't have anything to do with arcs and sparks. It just simply is designed to keep dust out. Hermetically sealed. Completely sealed from the atmosphere, usually done by fusion or brazing or welding. In the mechanical side of things, one general way to tell that something is hermetically sealed is that it does not come with any kind of taps on there for you to work on it from the factory. You would have to add those taps. Usually you're going to see equipment that is 5 pounds or less be hermetically sealed on the mechanical side of things. Non-incentive circuits. Big word. Worth talking about. Might spark under normal operating conditions, but it might not release enough energy to cause ignition. However, the circuits may contain enough energy for potential ignition if the equipment and the process fails. So it's not completely foolproof. Non-incentive component. It may spark under normal operating conditions, but it must not release enough energy to cause ignition. The housing of the non-incentive component is not intended to keep out flammable atmospheres for this reason. 500.3 Other articles. Unless modified in Chapter 5, all installation requirements that you find in Chapters 1 through 4 still apply. It's worth continuing to note that. Just because we're not in Chapters 1 through 4 anymore, and we're in the 5 through 7, which is basically there to modify Chapters 1 through 4, if it's not mentioned or modified in these chapters, the first 4 chapters still apply. Combustion principles. If we're going to talk about combustion principles and really break it down, we're going to have to talk about what it takes to actually create combustion, okay, which is fairly simple. Some people overcomplicate this and make it really difficult. Some of these fire triangles is what they're called, will have 20 or 30 different layers. Now, in reality, as tradesmen, we know that it takes a certain mixture, fuel to air mixture, in order for combustion to happen properly. Okay, but there are all kind of variances, plus and minus, that the combustion can still happen, but not be complete combustion. It could be dirty combustion. So we're going to look at this very simply, and we're going to say that in order for combustion to occur, we have to have a fuel. We have to have some sort of fuel, right? And our potential fuel types that we're talking about here deal with our classifications of hazardous locations. That's what we're talking about. So we could have combustible fuels, which oftentimes we're talking about natural gas or LP gas, especially if we're talking residentially speaking. But then we could also be talking about grain dust or textile dust. Okay? And those would have to be suspended in the air in sufficient quantities to create a hazard. So in order to have combustion, we also got to have enough air. And I have to have a good fuel to air ratio to support that flame. So if you're going to measure the air, especially in a combustion scenario, you're going to have to know what you're starting with in order to know what you're supposed to end up with. So in the air that we breathe, it's not rocket science. We don't have 100% oxygen in that air. What we have is 78% nitrogen, and under normal everyday circumstances, at what's considered a low temperature heating point below 2000 degrees, nitrogen and oxygen oftentimes will not have any kind of chemical reaction, and so the nitrogen will pass through the combustion process unscathed. We have roughly 21% oxygen, so nowhere near 100% in the air that we breathe. Any combustion that we have is going to diminish that. It's going to use that oxygen up, create chemical reactions and such that are going to make it so it's not pure oxygen that we can use anymore. And then of course 1% is considered other gases, things that are basically non-conducive to the situation. They have no bearing either way. And then we've got our fuel types. We've got our air. We have to have something to start the fire, right? So we got to have some sort of a heat or ignition source. A heat or ignition source could be as simple as an open flame. Somebody smoking a cigarette or lighting up a match or a lighter. It could be just an incendiary flame that we've got going on. It could be a spark from contacts making in a relay or on a contactor or a motor starter or something like that. Or it could be basically a friction spark, a static spark. And then we also could have pressure. At this point in the game as tradesmen, Most of us understand the game that we're playing, and that game involves manipulating pressures and temperatures. If you can manipulate something to the point in which the pressure goes up, when the pressure goes up, the temperature goes up, which allows you to control the combustion process. 500.5a, classification of locations, deals with where everything's going to be put. That's really what it comes down to. Classifications deal with human safety, but also it deals with what products are going to go into those locations to keep that human safety going. And obviously we don't want the building to burn down either, but that goes along with it. Human safety's got to come first. So the main thing is, in order to reduce the expensive equipment and wiring methods that would have to go in Division 1 locations, always know where that brake line is in Division 1, Division 2, so that you can install as much as possible out of the Division 1 location and in the Division 2 or beyond locations. They can communicate, but it would save you a boatload of money and ease of install if you can keep it out of there. 500.5b, Class 1, flammable or combustible gases, vapors, and liquids, which is Class 1. Again, the groups that are covered are groups A through D: acetylene, hydrogen, ether, hydrocarbons, fuels, and solvents, some of the more popular ones that we've heard of, common terms. Remember, in Division 1, in Class 1, we're talking about the flammable or combustible gases. The basic difference there is your flash point. Flammable is going to be below 100 degrees and combustible is going to be over 100 degrees for your flash point. That's all it is. Flammable or combustible gases, vapors, or liquids. Division 1, normally explosive and hazardous. Division 2, normally not in enough quantity to explode. Hazard's still there, normally not in this sufficient quantity. 500.c, Class 2, ignitable dusts. Ignitable dusts cover groups E through G, some of the more common ones. Metal dusts, electrically conductive and usually explosive. Carbon dusts, flour, starch, grain, combustible plastic, things like that for group D. Example here would be, for instance, I know of a tortilla factory, and at least some of the areas there are Division 1 or Division 2 Class C locations. Remember, the divisions for Class 2 deal with the amount of dust that's actually suspended in the air normally. So Division 1 is normally ignitable quantities suspended. So there's enough there and there's a good enough fuel to air ratio that we could have an issue. Division 2, normally not enough suspended quantity for an accident to happen. Could happen, but normally not enough there. And then 505D, Class 3, which are your fibers and flines. Usually when it comes into Class 3, oftentimes the groups that are covered are going to be textiles and woodworking areas, but there's no specific group. You're actually looking for the classification or chemical makeup of the dust in order to tell what the actual ignition qualities are of these. So it's actually a case-by-case basis in the textile and woodworking industry. Remember, here, instead of having gases in the air or dust in the air, now we're looking at where are we doing the textiles and woodworking. Division 1 is when it's being handled or used in manufacturing, and Division 2 is it's being stored or handled in storage exclusively in manufacturing. So still could have the accidents, because the danger is still there, but it's more unlikely that you won't. 500.6, looking at the material groups, again, class 1 groups out of 500.6a were groups A through D. Okay, some of the examples: acetylene, hydrogen, ether, and propane. Class 2 groups out of 500.6b are basically groups E through G, which include metal dust, electrically conductive and explosive, carbon dust, similar to coal, and flour, starch, grain, and combustible plastics would be your group G. 500.8, equipment. Article 500 through 504 require special equipment for special circumstances. So safety can be maintained to people and, of course, to the property as well. 500.8a deals with the suitability of that equipment. Suitability of equipment shall be determined by one of the following. 1, this would be 500.8a1, the listing and labeling. 2, the evidence of compliance by a qualified testing agency. 3, any other evidence acceptable to the AHJ, such as manufacturer testing, or potentially it's a product that you've asked for special installation provisions from the inspector, and he said, okay, if you get a third-party testing agency and they come back with findings that are acceptable to me, I'll let you put it in. Those findings would be something that would be acceptable in this category 3. 500.8b3, hazardous approvals. Where allowed in 501 through 503, you can have general purpose equipment or equipment in general purpose enclosures in Division 2 locations, providing the equipment normally does not constitute a source of ignition. And here's some examples. 500.8c, markings. Unless you see an exemption in 500.8c6, all equipment going into hazardous locations have to be marked to show the environment that they've been tested for, including C1 through 5 here, classes or the class, the division, only if it's for Division 2 only, material classification group, its equipment operating temperature rating of 40 degrees Celsius or higher, or ambient temperature rating if less than negative 25 degrees Celsius or greater than 40 degrees Celsius. Now let's look at a couple of those. C2, where we talked about division, and only if it's for Division 2. If the equipment is suitable for Division 1, then you can omit the division label because it's automatically allowed in Division 2. C4, the temperature rating of higher than 40 degrees Celsius. For Class 1 and 2 locations, the temp rating's got to be based on the maximum temp that the equipment could run at. If it were running with the maximum amount of dust it could possibly accumulate. The label shall have the temp ratings from the table at 500.8c, which uses what's called T codes. And C5, talking about the temperature rating again, markings have to be in Celsius. So you've got to make sure that you've got your positive and negative rated in Celsius on these labels. It's a universal label. .8c example. Okay, here's your example of a label. Okay, notice we've got our classes, divisions, groups. You also have your T codes on the far right with the C next to them for your Celsius label. And then you also see the listing marks on here. That 500.8c classification of maximum surface temps, I thought it would be prudent to go ahead and put this table on here so that you could see what those T codes actually are and what they relate to. So you notice they've got the Celsius marking and the Fahrenheit marking, which you might find on the label. But the Celsius is going to be your mandatory label that you're going to see pretty much on all labels. .8e 1 through 3 deals with threading. Pretty simple concept. Threaded entries into explosion-proof equipment shall be made up with at least 5 threads fully engaged if it's standard threads, or 8 threads fully engaged for metric threads. And all unused openings have to be closed with a listed metal close-up plug. 500.9 Specific Occupancies. Okay, there are tons of specific occupancies that are dealt with in Article 500. 500.11 deals with garages, repair, and storage. 513 aircraft hangars. 514 gas stations, motor fuel dispensing facilities. 515 bulk storage plants. 516 spray booths, spray applications and coating. 517 healthcare facilities. That's a real major one. If you work in healthcare facilities, you'll want to pay special attention to that. It seems to me, just my own opinion, that anytime you're working in a healthcare facility, you're always going to be following the most safety rules that you could possibly have. 518 assembly facilities like gyms, auditoriums, conference rooms, and restaurants, all examples given by the NEC. Article 550, mobile homes, manufactured homes, and mobile home parks. 550.1 covers the scope. Article 550 covers the conductors, equipment within or on a mobile and manufactured home, and conductors that connect mobile and manufactured homes to their electrical supply. 550.2 definitions. Got a big one right here. Manufactured home. A structure that is built on a chassis and designed to be used as a dwelling unit with or without a permanent foundation. So some folks decide, in their own head that, hey, that's not a manufactured home if it's got wheels on it. Well, that's not necessarily true. There are other provisions here. I have met people that have a manufactured home on a foundation and still have the wheels downstairs in the basement. So the wheels really have nothing to do with whether or not it's considered to be a manufactured home. Okay, so it could be with or without a permanent foundation. There are other provisions. Like I said, it must be at least 8 feet wide and at least 40 feet long, or at least 320 square feet. Those are all parameters given in the code. However, for the purpose of the article we're talking about here, the term mobile home includes manufactured homes. Okay, and there are lots of different examples that we've got. This one here is beautiful. I would never have guessed that that was a manufactured home. 550.4, general requirements. Hey, remember, when we're speaking about general requirements, these are things that apply throughout this entire section, this whole article, unless they're modified someplace else. So 550.4a, mobile homes not intended as a dwelling unit. Well, what would you be talking about here? Well, probably the most common would be a job site trailer. A mobile home not intended as a dwelling unit isn't required to meet the 100 amp minimum circuit capacity requirements of 550.32c for a dwelling unit. Okay, and you'll see that picture down here below. .4b. What happens if a mobile home or a manufactured home is not actually in a mobile home park? Does it have the same compliance requirements? Mobile homes installed in some place other than mobile home parks shall comply with this article. So, pretty straightforward. Article 550.12, branch circuits required. You might be surprised to learn that the requirements in a mobile or manufactured home mirror the traditional homes. So let's look at those real quick. The lighting, same calculation found in Annex D. 3 VA times the square foot of the home divided by the voltage. Right? So that's your lighting calculation. Your small appliance circuit, you got to have 2 or more of those. They got to be 20 amp, 120 volt. You have to have 1 laundry circuit, 20 amp, 120 volt. When it comes to general appliance, if your appliance is cord and plug, normally what we're talking about here, fixed in place with a light or other receptacle on that circuit, you can only pull up to 50% of that circuit's load. Remember, that's the appliance and you've got other things on that circuit. Now, if the appliance is fixed but there is no other receptacles or lighting on that circuit, you can pull up to 80% of the circuit load. And then also, if you've got a cord and plug appliance that's not fixed in place, so you can move it around, you can also pull up to 80% of that load. When it comes to bathrooms, you got to have at least 1 circuit, 20 amp, 120 volt. And again, just like in traditional homes, you can't serve other rooms with that bathroom circuit. Worth remembering. 550.13, receptacle outlets. This section is going to cover types of acceptable outlets and, of course, their installation requirements. So, let's look at them. A, 550.13a, grounding type. All must comply. Okay, the receptacles have to be of the grounding type. They have to be installed according to 406.4, and they have to be a 20 amp or 15 amp 120 volt circuit unless it's to a specific appliance, and then it can be slightly different depending on the appliance. So we mentioned 406.4. Let's take a little bit closer look at that. .406.4, general installation of receptacles. Now, these requirements, again, the command in the code is shall be done in accordance with Part 3 of Article 210. But again, we're talking about Section 406.4. So 406.4a talks about grounding type, and it says for what you find, except what you find in 406d, all 15 and 20 amp branch circuit receptacles shall be the grounding type. And 406.4b says that receptacles as well as cord connectors that have equipment grounding contacts must be connected to an equipment grounding conductor. Pretty straightforward. And 406C basically lines out what your methods of groundings are. The equipment grounding conductor of the receptacle and the cord connectors shall, again, that's not a choice, that's a command in the code, be connected to the equipment grounding conductor of the circuit that is supplying the receptacle or cord connector. The branch circuit wiring method shall provide an equipment grounding conductor for that receptacle, period. That's 406.4c, methods of grounding. Not a lot of rocket science, but definitely not a lot of wiggle room. 406.4d, replacements. They must be done in accordance with 406.4d 1 through 6. Arc fault and ground fault receptacles shall be installed in readily accessible locations. Remember, it doesn't mean that it has to be a receptacle when we're talking about it in the code. Okay, but if we're using receptacles, they have to be in a readily accessible location. So, again, replacements. Grounding type. If there's a grounding means in the receptacle enclosure already, you have to use a grounded receptacle in the replacement. It's as simple as that. 406.4d2 talks about non-grounding type. If there's currently no grounding conductor in the receptacle enclosure, you must comply with A, B, and C. And what they say is non-grounding receptacles can be replaced with another non-grounded receptacle. Okay, so that is still okay. Okay, because if there is no ground wire in there to hook up to, and you're not going to be required to run a new one in this particular instance, then you can replace it with what's there. Non-grounding receptacles can be replaced with a GFCI receptacle as long as it's marked no equipment ground. And C, non-grounding receptacles can be replaced with a grounding type receptacle that is supplied through a GFCI and marked, again, exact words in the code, no equipment ground. 406.4d3, GFCIs shall be provided where required elsewhere in this code. So what's the exception here? Where the enclosure will not fit, it physically does not allow the girth of a GFCI receptacle. You can put a new version of the existing receptacle where GFCI is already provided and the receptacle is marked both GFCI protected and no equipment ground. Okay, so if you have the GFCI protection and you're replacing a receptacle with a non-GFCI protected receptacle after the fact, you're going to have to label that as well as the no equipment ground. 406.4d4, arc fault circuit interrupters. Where AFCI is required, the replacement should be done with one of the following: a listed AFCI receptacle, a receptacle already protected by a listed AFCI receptacle on that circuit, or 3, a receptacle protected by an AFCI breaker. And remember, some folks forget that this was not immediately effective in the code because the arc fault breakers had only newly become available shortly before, and still many of them were in the testing process. So this particular section of the code actually became effective on 1/1/2014 according to the National Electric Code. Now if you're not believing me, we're talking about the 2014 code, and if you go to page 282, not the handbook, the actual code, it actually will tell you on page 282 this very information. .406.4D 5. Tamper resistant receptacles. They must be provided where required by the other sections of the code. Okay, remember 406.12 is an other section of the code, and it says specifically for tamper resistant receptacles, tamper resistant receptacles shall be installed in accordance with 406.12 A through C. So let's look at those. 406.12 A, dwelling units in all areas specified in 210.52 that have 15 and 20 amp 125 volt receptacles, you shall use listed tamper resistant receptacles. Okay, not a whole lot of rocket science there. So everything that's in 210.52, whether it's section A is going to be pertaining to a lot of this as far as the headache, but the countertop receptacles, of course, are going to create a headache as well if you're not used to this. But everywhere in a dwelling unit that requires receptacles in 210.52, got to have tamper resistant receptacles. 550.13b, GFCIs. All 15 amp and 20 amp 120 volt receptacles that require GFCIs in a mobile or manufactured home are ones installed outdoors in compartments that are accessible from outside, bathrooms, in luminaires, lighting fixtures, kitchen countertops, or within 6 feet of a sink. 550.13f, receptacles not permitted. Hopefully, according to this picture, you are making the assumption that this one is not permitted. If you were the one that was looking at this trying to figure it out and can't really figure it out, maybe we better go back to the drawing board. 550.13 F1, no receptacles over or in a bathtub or shower. .13G, also speaking about receptacles not required, G2 says in the wall space behind doors that can be opened fully against a wall surface. So remember, we're in Article 550 here. We're not in a traditional home. We're talking about mobile homes. So if a door can be opened completely flat against a wall surface. So the interpretation that I've had from several of the code officials have said, if you have a door that basically has a little button hook opener, you don't have an actual handle on there, and it can open up against a wall completely flat, then they don't want a receptacle back behind that door. It also could be a door that when it opens up, the knob actually opens up into part of a closet opening, which allows the door to completely sit against that wall flat. 550.16, grounding. Grounding of the electrical and non-electrical metal parts in a mobile home shall be through a connection to the grounding bus in the mobile home panel board. The frame of the mobile home nor the frame of any appliance shall not be connected to the grounded circuit conductor of the mobile home. Okay, surprise, surprise, that we have a lot of the same principles at play when it comes to mobile homes. 550.25b, arc fault in mobile and manufactured homes. 15 and 20 amp 120 volt receptacles in these areas require arc fault protection. It's going to surprise you, but it's exactly the same as what a traditional home is. Remember, just because the dwelling unit is a little bit different doesn't mean that we diminish the safety of the dwelling unit. We're still concerned about people and property. 550.32, service equipment. 550.32a, the mobile home disconnect. A disconnecting means must be located adjacent to, here's that within sight from that we talked about in some of the earlier definitions, but not more than 30 feet from the exterior wall of the mobile home. So oftentimes it's going to be out in the yard, but remember, it's got to be adjacent to, in sight from, so we're not talking on the other end of a forest or the other side of a fence or something, but not more than 30 feet from the exterior wall of that mobile home. Okay, when it comes to manufactured homes, they can be located on the outside wall of the structure, just like a traditional home. You have a minimum ampacity of 100 amps, and it has to be 120 to 140 volt service. So one thing that is, in addition to this, worth noting, that there are height requirements for this as well. And the height requirements come in F. So 550.32F say that the height requirements for the service disconnect cannot be any lower than 2 feet from grade or any higher than 6 feet 7 inches from grade when the disconnect handle is in the highest position. So remember, you have a height requirement, okay, and this goes on the side of the home when it's mounted there for a manufactured home, but also we're talking about mobile homes that traditionally have these service disconnects mounted on a pole or something similar. It's got to be between 2 feet off the ground and 6 feet 7 inches off the ground. Article 590, temporary installations. 590.1 is the scoped Article 590, and it tells us that you're going to find in this article the temporary power and lighting requirements for emergencies, tests, renovations and construction, as well as, surprisingly enough, holidays and special occasions. 590.2, all installations. Okay, when we're talking about all installations, this is your baseline. This will apply to all of your temporary installations unless modified. So 590.2a deals with other articles. All requirements of the National Electric Code apply to temporary installations unless specifically modified in this article. So a lot of people look at temporary installations and think that they can go ahead and throw whatever together works and it'll be good enough. In reality, that's not true at all. All the requirements that are there in the code are still there in the code, even though it's just for a temporary installation. So it's very important to remember that going forward, so that way when you're dealing with this stuff, out in the actual field, you're taking life safety into account. 590.2b, approval. Temporary wiring methods are acceptable only if approved based on the conditions of use and any special requirements of the temporary installation. So, when it comes to approval, who do you suppose has the ability to approve and not approve this stuff? Exactly. Your authority having jurisdiction, your inspector. Hopefully all of your installations look just this nice, but chances are not everybody's does. .3 deals with time constraints. So time constraints generally are referring to how long you can have these temporary situations sitting there. And 590.3a talks about that durational period. Temporary electrical power and lighting installations are only permitted during the period of construction, remodeling, maintenance, repair, or demolition of the buildings, structures, equipment, and similar activities. When the construction is done or the temporary scenario has been remedied, so now it's a permanent scenario, all the temporary stuff's got to go away. The approval's over at that point. 590.3b deals with holiday lighting as well. It says you only have 90 days to keep up holiday lights. So for some of you folks that keep your holiday lights all stapled up all year round, in your area, chances are if you've always done it, your inspector's fine with it. However, if you read the code as is, in a very direct approach, you would see that it says very clearly that that's not allowed. And the interpretation also goes a little bit further and says you can't just unplug them. You have to take them down, which is, obviously adds a lot more to the job if you don't just unplug them. 590.3 dealing with time constraints in section D, removal. Temporary installations must be removed immediately when the temporary situation that you were using it for been taken care of. And we see this kind of stuff all the time. Maybe not this particular kind of stuff, but we see temporary installations all the time. Some may be a little bit worse than others. 590.4, general requirements. Okay, keep in mind that everything in the first 4 chapters of the NEC are going to apply to temporary installations unless they're specifically modified. One of those sections is GFCI. You still have to have ground fault circuit interruption protection and also your protection for personnel in place as well. That still applies even though it's a temporary scenario. 590.4 general requirements. 590.4c deals with branch circuits. Okay, remember we're talking about temporary power and lighting. So this is dealing with temporary scenarios. All branch circuits still have to originate from an approved power outlet, panel board, or enclosure as well. So for this section, you'll also see that non-metallic cable like Romex should be able to be used with no limitation for height or construction type and doesn't have to be concealed in walls, ceilings, and floors. So if you're wondering why you see your basic non-metallic cable used on job sites for temporary scenarios, it's because its limitations are a lot less than some of the other types of wiring methods that you could use. Okay? And plus, just all around, it's quicker and easier to use. 590.4D1 talks about receptacles. All receptacles shall not be on the same circuit as temporary lighting on a construction site. Shall not is a huge saying there. So what they're telling you is you cannot put receptacles on the same circuit as temporary lighting on this construction site. And they've got to be connected to an equipment grounding conductor so that the overcurrent device, like the breaker, is going to trip properly. And they have to be GFCI protected. So in brief overview on this one little important section here, it tells us that you could GFCI protect the lighting circuit if you wanted to. There's nothing that prohibits you from doing that. However, you're not killing two birds with one stone, meaning putting the lights and receptacles on the same circuit and GFCI protecting it all so you run less wire. You're not allowed to put the receptacles on the same circuit as the lighting. So oftentimes you're seeing folks that will run the lighting separate, of course, and not GFCI protected, while running the receptacles on a GFCI protected circuit because that's actually required. .590.4F says your lamps have to be protected, right? And that's a shall statement. Lamps shall be protected from accidental damage by contact with the use of a lamp holder with a guard. .590.4G talks about splices. No boxes are required for splices or junctions on a construction site as long as the equipment grounding continuity is maintained. So we don't have to necessarily follow all the same principles because this is one section that's modified a little bit. We don't have to have the splices inside of a box as long as its ground is maintained and the method that you've used is giving it proper insulation and personnel protection, as well as being suitable for the environment that it sits in. .590.4H talks about protection from accidental damage. Cords and cables shall be protected from damage. We're talking about rollover damage as well as sharp corners, vibrations, heat, all that kind of stuff. And there's some pretty ingenious ways that folks do this. Some of these products are really pretty cool. They work well, they're durable, and they also look pleasing on a construction site. They don't make it look all bulky and as much of an eyesore as what you would think. .590.4 general requirements in I. Termination at the devices. When terminating flexible cords and cables in a box, they have to be secured with fittings listed for that purpose. .590.4J. Supporting. Cable assemblies, flexible cords should be supported and spaced appropriately for the location to ensure that there's protection from physical damage. Okay, the support, of course, is going to be determined by your local inspector. There's not a lot of guidelines in the National Electric Code, okay, but there are job site conditions that are outlined in 590.2B. And it's also important to remember that new to the code in 2014, extension cords do not apply to this rule. .590.6 ground fault protection for personnel. All temporary wiring supplied that can be used by personnel, by people, shall have ground fault protection. It doesn't matter whether the power is derived from the power utility or if it's site derived, like solar or gas powered generator. Makes no difference. You still have to have GFCI protection for personnel. 590.6A1, receptacles not part of the permanent wiring. So we'll look at this in a little bit more depth. All 15, 20, and 30 amp 120 volt receptacles used by personnel shall have GFCI protection. Listed cord sets that have integral GFCI protection are allowed. So this is one area that's modified as well, above and beyond what Article 210 talks about. It says that all 15, 20, and 30 amp receptacles. So it used to be 15 and 20 amp in just a general sense for residential dwelling use. Now we're talking about 30 amp as well. 590.6A2, receptacles existing or installed as part of permanent wiring. This portion here may be easier described as permanent receptacles used as temporary power. All 15, 20, and 30 amp 125 volt receptacles that are existing in the structure and may be used even if temporarily for power during construction by personnel shall have GFCI protection. Listed cord sets that have an integral GFCI protection are allowed. Now we're talking 590.6A3, receptacles on 15 kW or less portable generators. Again, 15, 20, and 30 amp 125 volt receptacles on portable generators up to 15 kW in size shall have GFCI protection. Again, listed cord sets that have integral GFCI protection are allowed. Now we'll move on to a completely new section. A completely new section for us in this presentation. It's obviously not new in the code. However, this is a largely expanded section in the 2014 code book. Article 625, electrical vehicle charging systems. 625.1 deals with the scope, the general overview of this section. This article covers the installation and safety related to the equipment and devices related to electric vehicles. 625.2, definition of an electric vehicle. A vehicle that has a motor primarily powered, not completely powered. Okay, it could be, but it doesn't have to be. It says primarily powered by electricity and is for on-road use. These include automobile, bus, truck, van, neighborhood vehicle, and motorcycles. Right? There's some pretty cool ones out there. The industry's come a long, long ways. (625.5), having things listed or labeled. All electrical materials, devices, fittings, and associated equipment must be listed or labeled for the purpose. Part 2, the equipment's construction. 625.10, electric vehicle coupler. Okay, this is the actual section where we talk about hooking up the electric vehicle for charging purposes via coupling unit to the charging device or the power supply. Electric vehicle charging coupler shall comply with 625.10 A through F, and they are polarization. Coupler must be polarized. B, non-interchangeability. Coupler cannot be configured in a way that allows it to be wired in and used on other electrical systems. It doesn't say that it can't be used on other electric vehicles other than yours, but it says it can't be used on other electric systems. Construction and installation. It shall be made and installed in a way that prohibits inadvertent contact between live parts and people. Unintentional disconnection. It must have measures that prevent accidentally being disconnected. And we're continuing. E is grounding pole. It must have a grounding pole integrally or set up as an isolated system. And the grounding pole requirements say that the grounding pole has to be set up or constructed so that it makes contact to the equipment first and breaks contact first as well. (625.15). More particularly, Section B. Ventilation not required. Mechanical ventilation is not required for electric vehicle storage batteries or equipment where it has been listed or labeled as suitable for charging electric vehicles indoor without ventilation. The equipment has to be marked, clearly marked, stating ventilation not required on the device. It shall be visible even after installation, and that's a code requirement. Okay, primarily what we're looking at here is, there are some batteries that while being charged, they put an off gas into the surrounding environment. And of course, if there's an off gas in the surrounding environment, it could be dangerous to humans or even be flammable or explosive, dangerous to the surrounding structure. And so ventilation would be required. If that's not the case, then it would not be required, but it has to have the clearly marked label stating that ventilation is not required. And then 625.15 C, dealing with ventilation required, is the same thing. Okay, if the supply equipment is listed or labeled as suitable for charging electric vehicles that require ventilation, the ventilation must be included. Okay, and it has to be clearly marked, according to code, as ventilation required, those exact words, and it's got to be visible even after it's installed. (625.17) Cords and cables. 625.17C more particularly deals with the overall cord and cable length. They shall not be longer than 25 feet measured from the coupler back unless a listed cable management system is used. 625.19 Automatic de-energization. This, of course, is going to be meant to protect the people and the structure in case the cord fails and falls into a wet or flammable environment. The electric vehicle charging equipment has to automatically de-energize the connector and conductors in the case of severe strain or in the case that the cord gets pulled out. 625.22 Personnel Protection System. They shall have a means of disconnect in the cord or on the attachment plug for personnel protection. If it is in the cord, it can't be any further than 12 inches from the attachment plug. Notice the picture here. And the GFCI protection would be optimal at this point, of course, on the circuit, and it would be, certainly located inside of the attachment cord or the plug. In addition to all this, the entire circuit has to have GFCI protection. Part 3, Installation. 625.40, overcurrent protection. Being sized for continuous duty is mentioned in this section here as well as in 625.41. Overcurrent protection for circuits supplying electric vehicle supply equipment must have a rating of not less than 125% of the maximum load of the electric vehicle supply equipment. They shall also be sized for continuous duty. 625.41 rating. Charging loads for electric vehicles are considered to be continuous duty and is sized off of the electric vehicle supply equipment rating. 625.46 loss of primary source. This section is pretty easy. If you lose your primary source of power that's feeding the charging equipment, you certainly don't want the power to start feeding backwards from the car through the charging equipment into the circuit in the house. That's all we're talking about here. 625.50 location. What about the height requirement? The coupling means the electric vehicle supply equipment must be located at a height of not less than 18 inches and not more than 4 feet above the floor. So we're talking the coupling means has got to be in that range. So between 18 inches and 4 feet above the floor. Location. The electric vehicle supply equipment must be located so that it permits direct connection from the vehicle connector to the electric vehicle. Okay, obviously, no uses of extension cords or anything like that are going to be permitted. 625.52, talking about ventilation again. The ventilation not required. Mechanical ventilation not required for electric vehicle storage batteries or equipment where it has been listed or labeled as suitable for charging electric vehicles indoor without ventilation. Okay, again, it has to be marked ventilation not required. 625.52, dealing with the ventilation being required. Okay, if it's suitable for charging indoors, but it has to have ventilation, it's got to be clearly marked. Ventilation required. And again, just as before, it has to be visible even after the installation. Article 640. Moving on. Audio processing, amplification, and reproduction. (640.1) talks about the scope. And as all of the other articles, the scope covers your equipment and wiring for audio signals in a general sense. Gives you an idea of what's to be found in this chapter. Article 640 covers equipment and wiring for audio signal generation, amplification, recording, processing, and reproduction. It includes sound for public address systems and includes temporary audio systems like concerts. Some examples where you may find audio systems covered by this article would be hotels, restaurants, offices, auditoriums, churches, and schools. (640.1) B. What's not covered? It does not cover the installation of fire or burglary alarms. (640.2) Definitions. Abandoned cable. A cable that isn't terminated and isn't identified for future use with a tag. Amplifier. Electronic equipment that increases the current or voltage potential or both of an audio signal and is intended to be used with another piece of equipment. Auto transformer. A transformer with a single winding and multiple taps intended to be used with an amplifier, loudspeaker, signal output. Audio transformer. A transformer with two or more electrically isolated windings and multiple taps intended to be used with an amplifier, loudspeaker, signal output. 640.3 Other articles. Circuits and equipment shall comply with 640.3A through M. And keep in mind, penetrations have to be closed up, as though no hole was ever made. If it requires a fire stop rating prior to it, you have to make sure that it has the fire stop rating after it, because A originally begins with the spread of fire and fire products of combustion. And it says 300.21 applies. So we're talking about other articles here, and we're talking about the applicability of these specific other articles to Article 640 dealing with the audio installations and operation of equipment. So we're basically saying if you make a hole in a structure, that structure, if it required fire stop before, it has to have fire stop installed when you're done. 300.21 says electrical installations in hollow spaces, vertical shafts, and ventilation or air handling ducts have to be done so that you don't increase the flame spread potential. Pretty straightforward. B. Ducts, plenums, and other air handling spaces. See 300.22 for spaces that deal with environmental air. They shall be plenum rated unless they're installed via a wiring method accepted in Chapter 3. When it comes to 300.22b, we should probably look at that. 300.22b, wiring in environmental air ducts. Ducts that carry heating and cooling and ventilation are only allowed to have wiring methods in or through them if it's necessary to make the equipment operate properly or accessory equipment operate properly, or if the product is listed for the installation and the AHJ allows the installation. That's a two-step process. If it's listed and the inspector allows you to do it. 300.22 does have some exceptions in it. 300.22c exception allows passing through joists or studs used in environmental air. .3 still in other articles. Hey, we're going back now. We just took a look at 300.22 for a second. Okay, we looked at A and B because they were very pertinent and they were very common. Okay, the rest of these are somewhat common for some of them, and other ones are a little more obscure, so we're probably not going to look into each one of these in the detail that we did the ones before. So let's look at this. C, cable trays. you'll see Article 392. D, hazardous locations. We spoke about that just a short while ago. See Chapter 5, Article 500. E, assembly occupancies. See Article 518. Theaters, you would see Article 520. Carnivals and circuses, see Article 525. And motion picture studios, see Article 530. To continue on, I will be pools and fountains. See Article 680. J, combination systems, used when the AHJ allows the audio system to be combined with the fire alarm system. See Article 760. K is antennas. See Article 810. L, generators. See Articles 445.10 through 445.12 and 445.14 through 445.16 and 445.18. If it's a portable generator that needs to be grounded, see Article 250.34. And last but not least, M, dealing with organ pipes. You'll see Articles 650.4 through 650.8. And again, not to diminish any of these ones we didn't go into detail in. These you can detail on your own. You should have access to this program for at least a while after you're done completing it. So you'll be able to go back and do some self-study on this. Okay, the point here was to give you some examples in the beginning, which we did in A and B, which we referenced back to Article 300 and prior to that even. So looking at this section of the code requires some finesse. I mean, we're talking about audio wiring here, and a lot of people don't know exactly what's in the code book that deals with audio wiring, let alone the amount of referencing back and forth that it takes to actually properly do it. So that's why we're talking about it right now. You have several areas that will need to be referenced in order to properly install your audio cables. Moving on to 640.5, access. Access to the equipment shall not be impaired because of panels, including ceiling panels or accumulation of wires. .6 deals with mechanical execution of the work. Okay, look, when you're out there on the job site and you're putting in these audio cables, it shouldn't look like you closed your eyes and threw them straight up in the air like spaghetti string. They should be put together in a neat and orderly fashion, and really the way that it ends up looking is going to be in the eye of the beholder. You're going to say, okay, this is the best that I can do, and the authority having jurisdiction has in his mind what's acceptable to the area that he inspects for, and hopefully you have the meeting of the minds. Sometimes this stuff is overly neat, and in reality, that's the way it should be. The best job we can do, best foot forward each time. So let's look at some of this stuff. The equipment and cabling must be installed in a neat and workmanlike manner. Exposed audio cables have to be supported in a way that they'll not be damaged, and by listed hangers, straps, etc. You see Articles 300.4 and 300.11a for some guidance on that. Accessible areas of abandoned cables shall be removed, and cables installed for future use have to be marked with the date of identification for future use and the date of intended use and any additional information that's pertinent to the job. 640.10 Audio systems near bodies of water. 640.10a Branch circuit power. Audio system equipment supplied by a branch circuit shall not be located within 5 feet of the inside wall of a pool, spa, hot tub, fountain, or tidal high water mark. Also, must be GFCI protected as required by the other articles. So the other articles are still applying here when we talk about GFCI protection. Part 2. Permanent audio system installations. 640.21 The use of flexible cords and cables. Flexible cords and cables are permitted between speakers and branch circuits, between speakers and amps or just speakers, between equipment and power supplies for other than branch circuit power like transformers or storage batteries, and between racks and the premises wiring system. Okay, the requirements here also state that for the permanent audio installations, you shall comply with Article 725. Article 725 specifically deals with power limited circuits. The difference between permanent and temporary installations is that you have to take into account Article 400 when dealing with temporary installations in those matters where you're going to be taking the stuff down and moving it around. Article 400 deals specifically with requirements for flexible cords and cables. 640.22 The wiring of equipment racks and enclosure. Metal racks and enclosures shall be grounded, whether permanent or temporary, doesn't make any difference. Okay, they don't have to be bonded if the rack is connected to a technical ground. Part 3. Portable and temporary audio system installations. Boy, what a nice setup we've got here. 640.41 Multiple branch circuit cable connectors. Some things to keep in mind in supplying power in temporary situations. Cords and cables cannot have tension on them that's transferred to the connections when connected to the equipment and powered up. It should go without saying there. The power supply cord shall have the female end connected to the load. Okay, so now we're getting a little bit more chintzy in our requirements here. We're getting real specific. The cord has to be rated in amps and be constructed so that dissimilar rated devices cannot be connected together. 640.42 The use of flexible cords and cables. Flexible cords and cables are permitted in these areas. Okay, but in looking at these, 640.42 B, C, and E all have to use extra hard usage cords or cables for the temporary use. The requirements here also state that for the permanent and temporary audio installations, you shall comply with Article 720 or 725, excuse me. Again, Article 725 specifically deals with the power limited circuits. So, looking at these, flexible cords and cables are permitted between speakers and branch circuits, between speakers and amps or just speakers, between equipment and power supplies other than branch circuit power like transformers or storage batteries, and between racks and the premises wiring. Now, where is this different than what we talked about earlier? In 640.21? Well, there are just a few really different examples, because before we were talking about permanent audio system installations in Part 2 and 640.21, which dealt with very similar requirements as we're seeing here, whereas now we're not. Now we're dealing with portable and temporary audio system cables. So if this portion of the presentation seems like the same thing you just learned, remember, it's a little bit different because it's dealing with portable and temporary, whereas what we talked about just a second ago was dealing with permanent installations. Chapter 7, Special Conditions. Article 700, Emergency Systems. 700.1 deals with the scope of this chapter. This article applies to the safe installation, operation, and eventual maintenance of emergency systems for supplying power or lighting or both in a power outage. (700.2) Definition. Okay, we're going to look at the definition of an emergency system. Those that are legally required and classified as emergency by the state, federal, and local authorities. They're required to supply power and or lighting in case of a power outage. And we see these most often in public facilities, whether it be office buildings or areas that are frequented by the public. 700.3 Tests and Maintenance. To keep systems operating the way they should be, you've got to conduct some tests. Okay, so what are those tests? Conduct a witness test. Complete the test of the system by the AHJ. You've got to have them tested periodically. Those are intervals that are accepted to the AHJ. Do battery systems maintenance. Make sure the proper charging and operation of the batteries. And test under a load. Make sure that the system is tested under its maximum anticipated load. So when you're looking at this, you've got initially here in the A section, the witness test. The whole system is tested by the AHJ, and then it's got to be followed up periodically with whatever the AHJ says is acceptable for the intervals, just to make sure it's working the way that it should. And then you got to check to make sure that the batteries are still in good repair. And you've got to test it under a load. Give it the maximum possible worst situation load that it could be operating under, and that's when you want to test it. 700.6 Signals. Signals shall be provided where possible to indicate derangement, what's not working in sequence or properly. Carrying a load, that the battery is carrying the load, that is not functioning, that the battery charger isn't working properly, and ground fault, that a ground fault has occurred. And D only applies to solidly grounded Y systems, so three-phase Y systems that have more than 150 volts to ground, that have circuit protected devices rated at least 1,000 amps. So, in looking at this stuff, what are we actually talking about here? We're talking about emergency systems, and we're talking about the signals. Okay, so the signals that we're talking about here are what happens when a problem occurs with your emergency system. Okay, so the emergency system, what they're saying here in the different sections, should signal you if it's not working properly in sequence. Okay, so things are out of order. If the battery's carrying the load, which means that the power has been cut, or it's failed, and now the battery is working. So if the battery is working in a non-emergency situation, or an emergency situation has occurred, but very little indication is given because of the lighting sequence, the battery carrying the load should be indicated to the people around. So you've got to have some sort of signal on that. And if it's not functioning properly, if the battery charger is not functioning, it won't charge the batteries in an emergency situation, that's going to cause an issue. So you have to know about that even when a non-emergency is happening. Okay, so general everyday business is running, it's operating, and the battery charger stops working. They should know about that so they can get it fixed before an emergency actually occurs. And then a ground fault. If a ground fault has occurred, but here, like we talked about, it's there's very specific circumstances here. A three-phase Y system, and only if you've got more than 150 volts to ground. Circuit protective devices rated at least 1,000 amps. 700.7 signs. 700.7b grounding. When removing a grounding or bonding connection in normal power source equipment, it interrupts the grounding electrode conductor in the alternate power source. So a warning sign has to be posted at the normal power source equipment saying, warning, shock hazard exists if grounding electrode conductor or bonding jumper connection in this equipment is removed while alternate source is energized. (700.8) Surge protection. A listed surge protective device shall be installed in or on all emergency systems. Okay, no different than most other systems. Part 4, emergency system circuits for lighting and power. These are more specific. 700.15, loads on emergency branch circuits. Emergency circuits must supply no loads other than those required for emergency use. Okay, so this is very specific in saying that you're not going to tap into the regular lighting load in order to supply your emergency load. This means no other non-emergency appliances or lighting are going to be on that load. 700.16, emergency illumination. The emergency illumination system shall include all required means of egress lighting. Okay, you'd hate to be inside the interior of a building where there's no window lighting or any kind of lighting and have to get out of that building. So what they're saying here is you've got to light the way out, the egress lighting. Exit signs and all other necessary lighting also has to be lit. It has to be designed so that any individual light failure will not leave an area that is required to have lighting dark. This also includes the area where the indoor service or building disconnect is located as well. (700.19) multi-wire branch circuits. Very simple. Multi-wire branch circuits are not allowed for emergency power and lighting circuits. Chapter 8, Communication Systems. (800.44A4) clearance. Fairly common setup that we've got here. Supply service drops and sets of overhead service conductors that operate up to 750 volts that run above, but parallel to communication service drops, have to have a minimum of 12 inches of separation anywhere. This includes the attachment to the building. Minimum of 12 inches separation, no matter where it is. The idea, of course, is to maintain enough distance that you eliminate the possibility of induction and as well nuisance interference on the communication wires. Okay, we've all seen horror stories before of lots of different wires running lots of different places. I'd imagine that their cable reception is probably not the best in some of these environments. (800.44b) above roof slopes. You have to maintain at least 8 feet of clearance vertically above all roofs. There are exceptions. Auxiliary buildings like garages, roofs sloped no less than 4 inches by 12 inches, and overhangs on roofs. Roofs that are sloped no less than 4 by 12 inches are allowed to get no closer than 3 feet. Okay, so the 8 foot is actually diminished to 3 feet. Clearances for overhangs on roofs are reduced to 18 inches as long as no more than 4 foot of communication service drop conductors pass above that overhang. (800.49) Metallic entrance conduit grounding. When entering a building with communications entrance wire contained in rigid or intermediate metal conduit, the wire shall be connected by a bonding wire or grounding electrode conductor to the grounding electrode. Part 4. Grounding methods. 800.100A. Bonding conductor or grounding electrode conductor. The bonding conductor may be insulated or bare and must be of copper or listed corrosion-resistant material. The bonding conductor shall be no smaller than 14 gauge and no longer than 20 feet. A separate ground rod for the communication system can be installed but must be bonded to the structural grounding electrode. It must be run as straight as possible and protected from damage. 800.100B1. Intersystem bonding termination. The ones you see here in the pictures, boy, are those nice. They're very slick looking. If the building is required to have an intersystem bonding termination, see Article 250.94, the bonding conductor for communication systems shall be connected to it. Great example. (800.100B2) has ground but no intersystem bonding termination. If the building is grounded but has no intersystem bonding termination and isn't required to, you shall connect to the nearest structural ground, grounded metal water pipe, power service accessible means, Article 250.94 for reference, non-flexible metallic service raceway, service equipment enclosure, grounding electrode conductor or its metal service enclosure, and grounding electrode conductor that's grounded to an electrode. Remember, on the water pipe, you have to have a water pipe that's in direct contact with the earth, and it has to be connected within 5 feet of its entrance into a building. So direct contact to the earth, 10 feet, but you also have to connect to it to make it a valid ground within 5 feet of its entrance into the building. Okay, and one thing that we've said as a basic underlying tone throughout all of the electrical classes that we provide is please make sure you check with your AHJ. Your inspector has to be okay with any of these means. There's some municipalities that don't require any of these or only require more than one as acceptable. 800.100B3. No ground and no intersystem bonding termination. If the building is not grounded and has no intersystem bonding termination and isn't required to, you shall connect any of the following individual grounding electrodes found in 250.52 A 1 through 4. Could be a water pipe, a metal structural frame, could be concrete encased, a grounding ring, a rod or pipe that's at least 5 foot long in direct contact with the earth, no closer than 6 feet from any other structural ground. Bonding of the electrodes, 800.100D. You have to use a minimum 6-gauge wire if bonding the communication system grounding electrode to the structural grounding electrode. Article 830, broadband. .100B3, no ground, no intersystem bonding termination. Requirements are very similar to the other communication wires with a couple of minor exceptions. Here's one. If you install a separate ground rod for the broadband system, it only has to be 5 feet long and 1/2 inch in diameter. So you don't have to maintain your 8-foot ground rod or anything like that. So when you're looking at that, you've got broadband requiring 5-foot ground rod, and you've got a DSL system that's going to require a 6-foot ground rod, and you have the normal ground rod for the structural portion of the building that's maintained at 8 feet, and you have a lightning rod that's maintained at least 10 feet. So keeping all of these straight can really be a challenge, but there are diminished amounts when no other is available.